Hello and welcome to another video of Learn with Visan Bastala. Today we will be learning about fractionation method. A standard fractionation tower consists of a vertical cylinder basils that enclose a number of bubble caps or perforated trays, or the more recently designed structure packing. The liquid feed containing the components to be separated is brought in around the middle of the tower and flows horizontally across each tray and in a downward direction until it reaches the bottom sum of the tower. It is important to maintain the level of liquid feed at a quasi-uniform level across each tray. The vapor that has been stripped from the liquid at the bottom of the tower slab some traverse the plates through perforation and continues upward until it reaches the top of the tower. As the vapor passes up through the thin layer of liquid or each plates, it mixes with the liquid and almost reaches equilibrium before passing upward to the next plate. The plates are so designed as to permit the liquid to pass across and downward from plate to plate. The perforation in the plates are sized to permit a sufficient flow of vapor to be in equilibrium with the quantity of liquid flowing across them. The vapor is supplied with a sufficient upward velocity to prevent the liquid from leaking through the perforation. Heat out, vapor, liquid down, vapor up, high volatility, low volume, product out, mixture in, product out, lower volatility. So oxygen is out from there, boiler, high volatility liquid. Liquid layer on plate, more volatile component evaporates and joins the vapor. Joins the layer. First one is typical fractionation column, and second one is transformation in the composition of both liquid and vapor during the intermingling on the fractionation plate. As the vapor of the more volatile component transfers the liquid on the plate, heat and mass balance through mass balance transfer occurs, thereby a small portion of the more volatile component in the liquid evaporates and enriches the vapor volume, whereas a small portion of the less volatile component bubbles, condense and joins the liquid. As bubbles of the vapor transverse the film of liquid 3.7b, heat is exchanged between the two phases. The less volatile component in the vapor condenses into liquid film on the trays, whereas the more volatile component in the liquid vapor vaporizes and is swept upward in the vapor. Within practical limitation of the pressure drops and power consumption, it is important to produce very small bubbles of vapor passing through the liquid to attain optimum condition of heat transfer and equilibrium balance. If the rate of the flow of vapor increases beyond the design point, it will impede the downward flow of liquid. Fourth thing will occur and the equilibrium balance will be destroyed. If, on the contrary, the vapor flow is below the design point, the liquid will drop through the perforation and dump to the sum. It is important before to operate the fractionation tower within the design parameters of liquid flow and vapor rate, so that a proper mixture of gases and liquid will exist. thereby attaining the correct equilibrium conditions between the two phases. In the sum of the upper lower pressure tower, the liquid, which is mostly oxygen, the less volatile component, is heated to release nitrogen. The more volatile component in the air separation plant. This heating, generally called reboiling, is accomplished with heat exchange from nitrogen supplied from the lower high pressure column. The reboiling oxygen is at a pressure of approximately 1.2 bar and 91.9 K, and the nitrogen is at a pressure of around 5.7 bar and 95.8 K. The difference of 3.9 Kelvin is enough to condense the nitrogen and vaporize the liquid oxygen. This condition was normal with the use of vertical copper tube vaporizes condenser. Presently, with the use of braced aluminum heat exchanger for vaporizer condenser, a temperature differential of 2 Kelvin and even slightly lower has been achieved. The ascending nitrogen vapor comes into intimate contact with a reflux of nitrogen rich liquid fed down from the top of the tower to complete the enrichment of the vapor. The top section is called the rectification or enrichment section of the tower. The bottom section is called the stripping section. Both terms here apply only to nitrogen, which is more volatile components. Thank you for watching. Tomorrow we'll be learning about fraction plates. Thank you.